Okay, so here's the thing. Nobody likes to admit out loud. We still can't explain why the universe exists at all. Not how it works, not what it's made of, why there is something instead of absolutely nothing. That's the question every other question quietly rests on, and science just sort of shrugs. If that already breaks your brain a little, good, you're in the right place. If this kind of stuff scratches an itch in your skull, do yourself a favor and hit subscribe. We post these every single week, and you can smash that bell too if you want your brain melted on schedule. Cool? Cool. Let me explain what we're actually getting into, because this is going to be a ride. We live in this golden age where it feels like science has cracked everything. We mapped the whole human genome. We photographed an actual black hole. We've got machines that can read the wobble of a planet orbiting a star trillions of miles away. And yet, when you really start poking at the foundations, the whole thing is riddled with holes. Massive ones. Questions so basic a 5-year-old could ask them, and the smartest people alive will go quiet and stare at the floor. So let's start at the very bottom, the deepest hole of them all. Why does anything exist? Picture this. You're lying in bed at 2 in the morning, the kind of night where your thoughts go to weird places, and it hits you. There didn't have to be a universe. There could have been nothing. No stars, no atoms, no space, no time, no you lying there thinking about it. Just nothing. And not even an empty room kind of nothing, because an empty room is still a room. Real nothing. No stage at all. And yet here we are. There's stuff. There's a whole entire cosmos packed with galaxies, and you're a part of it, made of the same atoms as those galaxies, somehow awake enough to wonder about it. Now, you'd think a question this fundamental would have at least the beginnings of an answer, right? Nope. Philosophers have wrestled with it for thousands of years. The German thinker Gottfried Leibniz framed it bluntly centuries ago. Why is there something rather than nothing? And here's the crazy part. Every answer anyone has ever tried to give just kicks the can down the road. Say the universe came from some prior physical law. Okay, then why does that law exist instead of no law? Say it came from a quantum field. Then why is there a quantum field instead of nothing? You can't escape it. At some point you hit a wall where you have to explain why there's a foundation at all, and there's no deeper floor to stand on. Science is fantastic at explaining how one thing leads to another inside the universe. But the existence of the whole thing? That's not a question physics has ever been able to touch, and honestly, it might never be able to. It's the ultimate unfinished sentence. And that's why everything else we're about to talk about sits on shaky ground. Because we are trying to figure out the rules of a game when we don't even know why the game is being played. Turns out that's a recurring theme. Get used to it. Now, let me take you somewhere wild. Let's go back to the beginning. Or well, what we think is the beginning. The Big Bang. You've heard the name a million times. You've probably pictured some giant explosion in the dark, fireworks going off in empty space. Forget that image because it's wrong, and the truth is way stranger. Here's the deal. Around 14 billion years ago, give or take, the best estimate puts it at roughly 13.8 billion years, everything that exists, every galaxy, every atom that would ever become a star or a planet or your left thumb, was packed into a point. And when I say a point, I mean unimaginably small, unimaginably hot, unimaginably dense. And then it expanded. Not exploded outward into space. There was no space to explode into. Space itself stretched and unfolded out of that point. The container and the contents came into being together. Try to picture that for a second and feel your brain start to slip. Yeah, that's the right reaction. But here's the question that should keep you up at night. What caused it? What actually set the Big Bang off? And the honest answer, the one scientists will give you if they're being straight with you, is that nobody knows. We can rewind the cosmic film all the way back to the tiniest sliver of a second after the Big Bang. We can describe what was happening when the universe was a fraction of a second old in stunning detail. But that very first moment, the trigger, the why, the what came before, the math breaks down. The equations stop giving sensible answers. We literally hit a wall called a singularity, where all our physics throws up its hands. So the single most important event in the entire history of existence, the one that made all of this possible, and we cannot explain what kicked it off. Let that sit with you. And it gets messier, because right after the Big Bang, something even weirder is supposed to have happened, and it's basically the duct tape holding our whole picture of the universe together. It's called cosmic inflation. Okay, so here's the problem. Inflation was invented to solve. When astronomers looked out at the universe, they noticed something that shouldn't be possible. The universe is way too smooth. Look at one edge of the observable cosmos and look at the opposite edge. Places so far apart that light, the fastest thing there is, could never have traveled between them in the entire age of the universe. They've never been in contact. They could never have shared heat or balanced out, and yet they're at almost exactly the same temperature. Eerily, suspiciously the same. That makes no sense. It's like walking into two separate sealed rooms on opposite ends of the planet that have never been connected and finding them at the identical temperature down to a tiny fraction of a degree. How? So physicists came up with inflation. The idea is that in the first absurd sliver of a second after the Big Bang, the universe didn't just expand, but it ballooned. Exponentially. Insanely fast. It blew up in size by a mind-bending factor in less time than it takes light to cross an atom. And before that violent stretch, everything had been close enough together to even out, to reach the same temperature, and then inflation flung it all apart while preserving that smoothness. It's an elegant fix. It actually explains the smoothness beautifully, and it explains a few other puzzles too. There's just one tiny problem. Nobody knows what triggered inflation. And here's the crazy part. Nobody knows what stopped it either. What flipped the switch to start this hyper-expansion? Unknown. What flipped it back off so the universe could settle into the calmer expansion we see today? Also unknown. We've got this incredibly important chapter in the story of the cosmos, a chapter that makes everything else line up, and we can't explain its beginning or its end. We just know it had to happen, because otherwise the universe we see wouldn't look the way it does. Which, if you think about it, is a pretty shaky thing to build your model of reality on. We needed something to have happened, so we say it happened, and we are still hunting for any direct proof and any explanation of the mechanism. Science being honest with itself, basically. Now, let me hit you with something that I think is the single most humbling fact in all of physics. You ready? Everything you have ever seen, touched, tasted, or even detected with the most sensitive instruments humanity has ever built, every star, every planet, every cloud of gas, every atom in your body and in this entire planet, all of it added together makes up only about 5% of the universe. 5%. That's it. The other 95% is made of stuff we literally cannot see and cannot identify. Let me explain, because this is one of the great open scandals of modern science. First, there's dark matter. Here's how we know it's there, even though we can't see it. Astronomers were watching galaxies spin, and they noticed something deeply wrong. Galaxies rotate, right? Like giant cosmic pinwheels. Based on all the visible matter in them, all the stars and gas we can actually see, the outer edges should be spinning slowly, lazily, the way the outer planets of our solar system orbit slower than the inner ones. But they're not. The outer edges of galaxies are whipping around so fast that by all our laws of gravity, they should be flying apart. The galaxy should be tearing itself to pieces and flinging stars off into the void. But it isn't. Something is holding it together. Something with a huge amount of gravity that we cannot see, cannot detect with any telescope, that doesn't give off light, doesn't reflect light, doesn't absorb light. We named it dark matter, and that name is basically a fancy way of saying we have no idea what it is. It's a placeholder. It's an IOU, and there's a lot of it. Dark matter outweighs all the normal visible matter in the universe by something like 5 to 1. It forms invisible scaffolding, vast webs of it, and the galaxies we can see are just bright little decorations hanging on a structure made of stuff we can't identify. Physicists have built underground detectors deep beneath mountains, shielded from all the noise of the surface, waiting silently for a single particle of dark matter to bump into them. Decades of searching, and so far, nothing definitive. The most abundant matter in the cosmos, and we've never caught a single confirmed piece of it. Wild. But dark matter isn't even the big one, because there's something even more mysterious and even more abundant, and it's called dark energy. Here's how we tripped over it. In the 1990s, astronomers were measuring how fast the universe is expanding. Now everyone expected the expansion to be slowing down. Makes sense, right? After the Big Bang flung everything outward, gravity from all that matter should be pulling it all back together, putting on the brakes, slowing the whole thing down over time. So they measured it, fully expecting to see the cosmic brakes being applied. And instead, they found the exact opposite. The expansion of the universe isn't slowing down. It's speeding up. It's accelerating. Galaxies are flying apart from each other faster and faster as time goes on, as if some invisible force is pushing space itself apart, fighting gravity and winning. This result was so shocking it won the Nobel Prize, and it broke everybody's brain. Because to make the universe accelerate like that, you need a colossal amount of energy spread through all of space, an energy that pushes instead of pulls. They called it dark energy. And here's the part that should make your jaw drop. Dark energy makes up the majority of the entire universe, around 68% of everything. The single most dominant ingredient in all of reality, the thing that determines the ultimate fate of the cosmos, and we have basically no idea what it is. None. We can measure its effects, we can put a number on how much of it there is, but what it actually is? Total mystery. So add it up. Roughly 68% dark energy, around 27% dark matter, and only about 5% the ordinary stuff that makes up everything you've ever known. Which means that the universe you experience, the entire visible cosmos in all its glory, is a thin film of foam floating on top of an ocean of complete mystery. 95% of reality is a question mark. And that's not some fringe idea, that's the mainstream, accepted, best we've got model of the universe. We are, quite literally, mostly in the dark. Pun absolutely intended. Now, speaking of things that should be simple but absolutely aren't, let's talk about time. Specifically, why time only ever moves forward. This one is so familiar that you've never questioned it, and that's exactly why it's so sneaky. You drop a glass, it shatters on the floor. You've never once seen the shards leap back up off the floor and reassemble themselves into a glass. You get older, never younger. You remember yesterday, not tomorrow. The past is fixed, the future is open. Cream swirls into your coffee and mixes. It never unmixes back into a neat little blob. Time has a direction. It flows one way, like an arrow, always forward. Obvious, right? Here's where it gets crazy. The fundamental laws of physics don't care about the direction of time at all. Let me explain. If you write down the basic equations that govern how particles move and interact, the deep laws, the ones underneath everything, almost all of them work exactly the same, whether time runs forward or backward. The math is completely symmetric. If you filmed two billiard balls colliding at the level of fundamental physics and played it backward, it would look perfectly normal, perfectly allowed by the laws. Nothing in the core rulebook of the universe says time has to flow forward instead of backward. The arrow of time just isn't built into the fundamental equations. So where does it come from? Why do we experience this relentless forward march if the underlying physics doesn't demand it? The leading idea is something called entropy, basically a measure of disorder, of how mixed up and spread out things are. The universe tends to go from ordered to disordered. The glass shatters because there are way more ways to be a broken pile of shards than to be an intact glass. The coffee mixes because there are vastly more ways for the molecules to be jumbled together than to be neatly separated. So things drift toward disorder, and that drift gives us a sense of forward motion. Forward is the direction in which the mess increases. Okay, fair enough. But here's the part nobody can explain. That whole argument only works if the universe started out in an incredibly ordered, incredibly low disorder state. For entropy to keep increasing for 14 billion years, you need to begin with something almost impossibly tidy and organized. And it did. The early universe was in a stunningly low entropy state. But why? Why did the universe begin so neat and orderly in the first place? There's no known reason it had to. Out of all the wild, chaotic, messy ways the universe could have started, it started in one of the most absurdly ordered configurations possible, and that single fact is what gives time its direction. Without it, there'd be no past and future as we know them, no memory, no cause and effect the way we experience them. And we have no idea why it was set up that way. The arrow of time, the most basic feature of your entire existence, the thing that makes you you and not some timeless smear, hangs on a mystery we cannot solve. Which just goes to show how the most obvious things are often the ones hiding the deepest holes. You'd never think to question time, and yet, when you do, the bottom drops out. Now let me take you on a trip out into the deep, empty parts of the cosmos. Because here's something that doesn't get talked about enough, and when you really picture it, it's genuinely unsettling. The universe is mostly empty. And I don't just mean the space between planets, or even the space between stars. I mean there are these enormous regions out there called cosmic voids, vast stretches of space, hundreds of millions of light years across, that are almost completely empty. Practically nothing in them. No galaxies, barely any gas, just yawning, silent emptiness on a scale your mind cannot hold. Let me give you a sense of how big these are. A single light year is the distance light travels in a year, and light moves fast enough to circle the Earth 7.5 times in 1 second. Now stretch that out to hundreds of millions of light years of basically nothing. There's one famous void that's so large it has astronomers scratching their heads, a region where there's a serious shortage of galaxies compared to what you'd expect. Across these voids, you could travel for an unfathomable distance and pass almost nothing at all. Picture this. You're a beam of light setting out across one of these voids. You travel and travel and travel for millions upon millions of years, and there's nothing. No star to pass, no galaxy to light up, just darkness in every direction, stretching further than the entire distance from us to most of the galaxies we can see. That's the scale of the emptiness. When astronomers first mapped the large-scale structure of the universe, this is what shocked them. They expected galaxies to be sprinkled out more or less evenly, like grains of sand scattered across a beach. Instead, they found something that looks almost organic, almost alive. The galaxies are arranged in vast filaments and sheets and walls, gigantic threads of galaxies strung across the cosmos like a spider web, or like the neurons in a brain. And in between those bright threads, these colossal empty bubbles, the voids. The whole universe on the largest scale looks like a sponge or a web of foam, with matter clinging to the edges of huge empty pockets. Now we have a rough story for how this happened. Tiny ripples in the density of the very early universe, slightly denser spots and slightly emptier spots, got amplified over billions of years by gravity. The dense spots pulled in more and more matter and grew into the filaments and galaxy clusters. The slightly emptier spots got drained, emptier and emptier, as their matter fled toward the denser regions, until they became these vast voids. Okay, that's the gist. But here's the thing. We don't fully understand it. The exact details of why the voids are as empty as they are, why some are so much larger than our models comfortably predict, why the whole web is structured the way it is down to the fine detail, there are still real gaps. Some of these voids are bigger and emptier than the standard picture says they should be. And remember, the whole thing is shaped by dark matter, that invisible scaffolding we already admitted we can't identify. So we're trying to explain the architecture of the entire universe using a building material we've never held in our hands. The grandest structure in existence, and we're squinting at the blueprints written in a language we only half understand. And here's the kicker that makes the voids hit even harder. If the universe keeps accelerating, keeps flying apart because of that dark energy we can't explain, then those empty stretches are only going to grow. Far in the future, the gaps between galaxies will widen so much that a civilization living then might look up and see only their own galaxy, with nothing beyond it but blackness. They'd have no way of knowing there was ever a wider universe full of other galaxies. The emptiness wins, eventually. The voids are a preview of the long, lonely fate of everything. Cheerful, I know. Okay, let me pull us back from the cold edges of the cosmos, because there's a mystery that's a whole lot closer to home. In fact, it's as close as your own face. Why do you cry? And I don't mean the kind of crying where you get an eyelash in your eye, or you're chopping an onion, or the wind hits you and your eyes water. That kind of tear has a clear job. It protects and lubricates your eyes. It washes out irritants. Every animal with eyes basically has some version of it. That's plumbing. That's not the mystery. The mystery is emotional crying. The tears that come when you're heartbroken. When you're standing at a funeral. When you're so overwhelmed with joy at a wedding that your eyes spill over. When a movie gets you right in the chest. Here's the wild part. As far as we can tell, humans are the only creatures on Earth that cry from pure emotion. The only ones. Out of every animal that has ever lived, every species, you, sitting there, are part of the only lineage that weeps from feeling. Think about how strange that is. Other animals feel things. They grieve, they show distress, they have rich emotional lives. Anyone who's had a dog knows that. But they don't produce emotional tears the way we do. A grieving elephant doesn't shed tears of sorrow down its face. A joyful dog doesn't well up. Only humans do this. We have a physical, visible, liquid response to our deepest feelings, and it pours right out of our faces for everyone to see. And the question that nobody can fully answer is, why? Why on earth did we evolve this? What's it for? Because evolution is usually pretty stingy. Traits that stick around generally do so because they help you survive or reproduce. So what's the survival advantage of leaking salt water out of your eyes when you're sad? At first glance, none. If anything, it seems like a liability. Crying blurs your vision. It signals weakness and vulnerability back in a more dangerous world, broadcasting that you're emotionally compromised could have gotten you hurt or worse. So why would natural selection keep a trait that seems to make you weaker at the exact moment you might need to be strong? Let me lay out the leading ideas because they're genuinely fascinating, and notice that not one of them is settled. The most popular theory is that emotional tears are a social signal. The idea is that crying is a form of communication, an honest signal that you're in distress and you need help or comfort. And it's honest precisely because it's hard to fake on demand. When you see someone genuinely crying, something in you responds. You soften. You want to help, to comfort, to connect. So crying might have evolved as a kind of glue for human relationships, a way to bond us together, to summon support when we're at our most fragile, to diffuse conflict by showing you're not a threat. We're an intensely social species. We survive by sticking together, so a powerful tool for triggering empathy and care in the people around you could absolutely be worth its weight, even if it makes you vulnerable in the moment. The tears say what words sometimes can't. Then there's a more chemical theory. Some researchers have suggested that emotional tears are actually different from regular tears in their makeup, that they might contain certain hormones and proteins related to stress, and that crying could literally be a way of flushing those stress chemicals out of your body. By this idea, crying isn't just a signal, it's a release valve, a way of physically lowering your stress levels, which is maybe why people so often report feeling lighter, calmer, almost cleansed after a really good cry. That post-cry exhaustion and relief you've definitely felt? This theory says that's your body chemically resetting. It's a tidy idea, and there's some suggestive research behind it, but it's far from proven, and other studies muddy the picture. And here's the honest truth. We don't actually know which, if any, of these explanations is right. It could be a combination. It could be something we haven't even thought of yet. One of the most universal human experiences, something every single person on the planet does, something that crosses every culture and every era, something so central to what it means to be human, and science still cannot give you a definitive answer for why it exists. You've cried, I've cried, every human who has ever lived has cried, and we are all participating in a mystery that nobody has solved. Which, when you step back, is kind of the whole point of everything we've talked about so far. The cause of the universe, the trigger of the Big Bang, the start and stop of cosmic inflation, the 95% of reality made of stuff we can't see, the direction of time, the vast empty architecture of the cosmos, and then, right down here on the human face, the tears you cry when your heart breaks. The biggest questions and the most intimate ones, and they all share the same answer. We don't know yet. Now, let me sit with that for a second, because I think it's actually beautiful, not depressing. We tend to think of science as this finished thing, a big book of answers handed down from the experts, all neat and settled. But that's not what science is at all. Science is an unfinished story. It's a process, a long argument with reality, and it's nowhere near done. Every single thing we've covered is a live, open question right now, today, with brilliant people losing sleep over it, building experiments, arguing in conference halls, chasing down clues. The frontier isn't some distant thing. It's everywhere, including in your own tears. And that's why this stuff matters. Because it's easy to walk around feeling like everything important has already been figured out, like we're just filling in the last few details. But the reality is the opposite. The deeper we dig, the more we realize how much we genuinely do not understand. 5% of the universe is the part we know about. 95% is the unknown. And that ratio is, in a weird way, an invitation. There is so much left to discover that we don't even have the words for it yet. Now, let's keep going because we've only scratched the surface, and I want to circle back through some of these and really sit in the strangeness, because the more you look, the deeper each one goes. Let me explain what I mean. Take the question of why there's something rather than nothing one more time, but from a different angle. People sometimes try to wriggle out of it by saying, Well, maybe nothing is unstable. Maybe nothingness naturally tends to produce something, the way certain physicists talk about particles popping in and out of existence in the quantum vacuum. And it's a clever move. But here's the catch, and it's a beautiful one. The quantum vacuum isn't actually nothing. It's a seething, energetic field governed by laws. It's a kind of something. So the moment you invoke it, you've smuggled in existence. You've assumed there are laws, there are fields, there is a stage for things to happen on. And then the original question just rears back up. Why is there a quantum vacuum rather than truly, utterly nothing? Why are there laws of physics at all? You can run, but you can't hide from this one. It is the bedrock mystery, and it sits underneath every laboratory, every equation, every telescope. We do all our science on top of a foundation we cannot explain. And here's the crazy part about the Big Bang that I want to drive home. When people first hear that the universe began 14 billion years ago, the natural question is, okay, what was there before? And the mind-bending answer that comes out of the physics is that the question might not even make sense. Because time itself may have begun with the Big Bang. There may be no before. Asking what came before the Big Bang could be like asking what's north of the North Pole. There's no direction left to point. There's no before to point to. Now, sit with how strange that is. Your whole intuition screams that every effect has a cause, that every event has a moment before it. And here, at the very origin of everything, that intuition might just break. Or, and this is the honest part, it might not. Maybe there was a before. Maybe our universe emerged from some prior state, some earlier cosmos, some larger structure we can't see. There are serious ideas along those lines. And the truth is, we cannot currently tell which picture is right. We are standing at the edge of the deepest cliff there is, peering into a fog, and we genuinely do not know what's down there. The trigger of the Big Bang remains, 14 billion years later, completely unexplained. And inflation, let me give you one more reason that one keeps physicists up at night. Remember, it's the thing that smooths out the universe and makes everything line up. But some versions of inflation theory have a wild consequence. If inflation happened once, in some versions it never fully stops everywhere. It keeps going in regions beyond our universe, constantly spawning new bubbles, new universes, each one its own pocket of reality with possibly its own laws of physics. This is the idea people call the multiverse. And here's the uncomfortable part. If that's true, it might be fundamentally impossible to ever test, because we could never see beyond our own bubble. So we've got a theory, inflation, that we kind of need to make our universe make sense, and one of its possible consequences is an infinity of other universes we can never observe. Is that science, or is it speculation? That's a genuine fight happening right now among brilliant people. And it all traces back to a process whose on switch and off switch we cannot explain. Wild that the smoothness of your night sky rests on something this shaky. Now, back to the dark stuff, because I don't think people appreciate just how embarrassing this is for physics, in the best possible way. Imagine you're a detective, and you walk into a room, and you can clearly see the effects of someone having been there. Furniture knocked over, footprints, a window left open. You know with total certainty that someone was here and did this. But you can't see them, can't photograph them, can't find a single fingerprint, and after decades of searching with the best forensic tools on the planet, you still can't say who or what they are. That's dark matter. We see its gravitational fingerprints all over the universe. Galaxies spinning too fast to hold together without it. Light from distant galaxies bent by its mass in ways we can measure precisely. The way galaxies cluster together. All of it screams that dark matter is real and everywhere. And yet, decades into the hunt, with detectors buried deep underground and particle colliders smashing matter together at nearly the speed of light, we have never once directly caught it. The most common matter in the universe is a ghost. And dark energy is even more humbling than that, because at least with dark matter, we have lots of candidate ideas for what kind of particle it might be. With dark energy, we're more lost. The best guess is that it's some kind of energy baked into empty space itself, that even a perfectly empty box of vacuum has a tiny bit of pushing energy in every cubic inch of it. And when physicists tried to calculate how much energy empty space should have, using our best theories of quantum physics, they got a number. And then they compared it to how much dark energy we actually observe. And the two numbers were off. Not by a little. Off by a factor so enormous, it's been called the worst prediction in the history of physics. The theoretical answer and the observed answer disagree by an amount with so many zeros, it's almost comical. So we know dark energy is real. We can measure exactly how much of it is out there, and our best theory of why it exists gives an answer that's wrong by a margin almost too large to write down. That, my friend, is a flashing neon sign that says there's something huge about reality we are completely missing. And it makes up the majority of the universe. Let me put the whole inventory in front of you one more time, because it really is staggering. The ordinary atoms, you, the Earth, the Sun, every star you can see with your naked eye, every galaxy in every photograph, about 5%. Dark matter, the invisible scaffolding holding galaxies together, around 27%. Dark energy, the mysterious push tearing the universe apart faster and faster, roughly 68%. We understand, even partially, only the smallest slice. The overwhelming bulk of reality is two things we named but cannot explain. If an alien civilization asked us to describe our universe, the most honest thing we could say is, well, almost all of it is a mystery, but the little corner we live in is pretty nice. And then there's time, which I keep coming back to because it's the one that messes with me the most. We talked about how the laws of physics don't care which way time flows, and how the arrow of time seems to come from entropy increasing, from the universe starting in a state of stunning order. But here's a thought that'll twist you up. Your memories, your sense of self, the feeling of being a person moving through life from birth toward the future, all of that exists because the universe happened to start in a low entropy state 14 billion years ago. Your entire experience of being alive, of having a past and looking toward a future, is downstream of that one inexplicable initial condition. If the universe had started in a high disorder state, there'd be no arrow of time, no cause and effect as you know it, no story to your life. You are, in a very real sense, a creature made possible by the orderliness of the early cosmos. And nobody can tell you why the cosmos was that orderly. The deepest root of your inner life is an unsolved problem in physics. Picture that next time you remember something. That memory exists because of a mystery. And then we come all the way back to your face, to those tears. And here's why I love ending this stretch on crying. Because it shows that the unknown isn't just out there in the cold reaches of space. It's not just dark energy a billion light years away. It's in you. It's in the most human thing you do. You can be the most rational person alive. You can understand the equations, and still, when you lose someone you love, water will pour out of your eyes, and not even the smartest scientists on the planet can fully tell you why. We are mysteries wrapped in mysteries, walking around on a planet in a galaxy held together by invisible matter, in a universe pushed apart by invisible energy, born from an event we can't explain, experiencing a flow of time we can't justify, asking a question, why does any of this exist, that has no answer. And somehow, that's not a reason to despair. It's the most exciting thing imaginable. Because it means the story isn't over, not even close. Every one of these holes is a place where a future discovery is waiting. Somewhere out there, maybe a kid alive right now will figure out what dark matter is, or catch the first real clue about what came before the Big Bang, or finally crack why we cry. The not knowing isn't a failure of science. It's the engine of it. The whole reason anyone bothers to build a telescope or a particle collider or to study the chemistry of a single tear is precisely because we don't know yet. The unknown is the fuel. So here's where we are. We can't explain why the universe exists at all. We can't explain what triggered the Big Bang or what started and stopped cosmic inflation. We can't explain 95% of what the universe is made of, the dark matter and the dark energy. We can't explain why time only flows forward when the deepest laws don't require it to. We can't fully explain the vast empty voids stretching hundreds of millions of light years across the cosmos. And we can't explain why you, alone among all the creatures that have ever lived, cry from the sheer force of your feelings. 6 enormous holes, and we're just getting started. Because there are dozens more where these came from, and each one is its own doorway into the strange, unfinished, wide-open story of everything. So stick around. We're going to keep falling down this rabbit hole together, and trust me, it only gets deeper from here. Okay, so where were we? Right, falling down the rabbit hole. And this next stretch gets weirder, because now we're going to leave the safe ground of stars and galaxies and walk straight into the part of physics that genuinely sounds made up. It isn't. It's the most tested, most confirmed science we have. It's just that nobody, and I mean nobody, actually understands what it means. Let me explain. We are talking about quantum mechanics. And here's the thing you need to wrap your head around first. Quantum mechanics works. It works better than almost any theory in the history of science. The predictions it makes have been confirmed to a ridiculous number of decimal places. Every smartphone, every computer chip, every laser, every LED, all of it runs on quantum mechanics. The technology in your pocket right now is a monument to how stunningly accurate this theory is. And yet, when you ask the simple question, okay, but what is actually happening down there? What does it mean? The smartest physicists on the planet start arguing and don't stop. We have a perfect instruction manual for the universe at its smallest scale, and we have absolutely no idea what the manual is describing. That's the setup. Now, let's get weird. Start with the most basic mystery. What even is a particle before you look at it? Here's the deal. Down at the smallest scale, things like electrons don't behave like tiny solid marbles the way you'd imagine. Before you measure them, they don't have a definite position. They exist in this fuzzy, spread-out smear of possibilities, a thing physicists describe with something called a wave function. The electron is, in some sense, in many places at once, a cloud of maybes. And then you measure it, you look, and the instant you do, that whole cloud of possibilities collapses down into a single definite spot. The electron is suddenly here, in one place, like it was all along. Picture this. It's like a coin that, while spinning in the air, isn't heads or tails, but somehow genuinely both, a blur of both outcomes existing together, and only when it lands, only when you catch it, does it become one or the other. Except for the electron, it's not spinning too fast to see. It's literally in a state of being all the possibilities at once, until the moment of measurement. Now here's the question that has tortured physicists for 100 years. What counts as a measurement? What makes the cloud collapse? Why does looking, observing, seem to force reality to pick a single answer? Does it need a conscious observer? Does it just need any interaction with the wider world? Nobody agrees. This is called the measurement problem, and it is the festering wound at the very center of our most successful theory. We can calculate exactly what the odds are of finding the electron here versus there. We nail those probabilities perfectly. But the question of why and how a fuzzy cloud of possibilities becomes one single concrete reality the moment it's observed, that we cannot explain. The math tells us what happens. It refuses to tell us why. And it gets stranger. Because there's an experiment, the most famous experiment in all of quantum physics, called the double-slit experiment. And it is so bizarre that the great physicist Richard Feynman said it contains the only mystery of quantum mechanics, the heart of the whole thing. Here's how it goes. You fire particles, let's say electrons, one at a time at a barrier with two narrow slits in it. And behind the barrier there's a screen that records where each one lands. Now, common sense says each electron goes through one slit or the other, like a tiny bullet, and over time you'd build up two stripes on the screen, one behind each slit. Simple. But that's not what happens. Instead, you get a pattern of many stripes, light and dark bands, the kind of pattern you only get from waves interfering with each other, like when two ripples in a pond overlap and cancel out in some spots and add up in others. So each single electron, fired alone, somehow behaves like a wave, like it went through both slits at once and interfered with itself. One particle going through two slits simultaneously, overlapping with its own possibilities. And here's the crazy part. If you set up a detector to actually watch which slit each electron goes through, if you try to catch it in the act, the wave pattern vanishes. The instant you observe the path, the electrons start behaving like ordinary bullets again, and you get the two simple stripes. The mere act of looking changes the outcome. The universe behaves one way when you're not watching, and a completely different way when you are. Let that sink in. Reality at its most fundamental level seems to depend on whether or not it's being observed. We've run this experiment thousands of times, refined it in every imaginable way, fired bigger and bigger objects through the slits, and the weirdness holds up every single time. It's rock solid, and it makes no intuitive sense whatsoever. We can describe it with flawless math, and we cannot tell you what it means about the nature of reality. A century later, that mystery is exactly as unsolved as the day it was discovered. Now, speaking of things that sound impossible, let me tell you about the one Einstein himself hated so much he called it spooky: quantum entanglement. Here's the setup. You can create two particles that are linked, entangled, so that their properties are tied together. Now you separate them. Take one and leave it here, take the other and carry it across the room, across the city, across the planet, in principle across the galaxy. They're connected. And here's the spooky part. When you measure a certain property of one particle, the other one instantly takes on the corresponding property, no matter how far apart they are. Measure one, and the other's state is fixed in the same instant, faster than any signal could possibly travel between them, faster than light. It's as if the two particles are sharing a single fate across any distance, with no wire, no signal, no connection we can detect. Einstein absolutely could not stand this. He called it spooky action at a distance, and he was convinced it meant the theory was incomplete, that there had to be some hidden information, some secret instructions the particles carried with them from the start, like two people who agreed beforehand what they'd each do. For decades, it was a philosophical argument. And then, here's the beautiful part, someone figured out how to actually test it. A physicist named John Bell came up with a way to mathematically tell the difference between Einstein's hidden instructions idea and the genuinely spooky quantum prediction. And when scientists ran the experiments, careful, rigorous, repeated, increasingly airtight experiments, Einstein lost. The universe really is that spooky. Entanglement is real. The particles really do seem to be instantaneously connected across any distance, with no hidden instructions. This work was so important and so mind-bending that it won the Nobel Prize in Physics. And yet, here's where we land again. Knowing that it's true doesn't mean we understand it. How can two particles share a fate across the entire universe with no connection between them? What does that say about space, about distance, about whether things are as separate as they look? We don't know. We just know it's real, confirmed, and completely baffling. And here's a question that comes right out of all this, and it might be the deepest one in physics. Why does mathematics describe the universe so well? Think about it. A human being sits at a desk and scribbles abstract symbols on paper, pure math, invented in their own head. And then it turns out those exact symbols predict how a particle no one has ever seen will behave, or how a galaxy will spin, or where a planet will be 1,000 years from now. The physicist Eugene Wigner wrote a famous essay about this, calling it the unreasonable effectiveness of mathematics. Why should the universe obey neat mathematical rules at all? It didn't have to. Reality could have been an arbitrary, lawless mess. Instead, it runs on equations so elegant that physicists routinely use beauty and simplicity as a guide to finding the truth, and it keeps working. Is mathematics something humans invented, or something we discovered, something that was already woven into the fabric of reality, waiting for us to find it? Nobody knows. It's one of the oldest and deepest questions there is. And our best, most successful theories only make it sharper. The universe is written in math, and we have no idea why. Okay, let me bring us back to something physical, something you can almost touch. And yet, it's another giant hole. Gravity. You'd think we'd have gravity figured out by now, right? It's the most familiar force in your whole life. It's holding you in your chair right now. Newton described it centuries ago. Einstein gave us an even more beautiful picture of it. And here's where the trouble starts. We actually have two grand theories of physics, and they're both spectacularly successful, and they flatly contradict each other. On one side, you've got general relativity, Einstein's masterpiece, which describes gravity and the very large, planets, stars, galaxies, the whole shape of space and time. In Einstein's picture, gravity isn't really a force at all. It's the bending and curving of space and time itself by anything that has mass. A heavy object like the sun warps the space around it, and the planets roll along those curves like marbles circling a dip in a stretched sheet. This theory is gorgeous, and it's been confirmed again and again. It predicted black holes, it predicted the bending of starlight, it predicted ripples in space itself that we've now actually detected. On the other side, you've got quantum mechanics, which we just talked about, describing the very small, particles and the other three forces of nature, in terms of probabilities and fuzzy clouds and discrete little packets, also confirmed to absurd precision. And here's the problem. When you try to put them together, when you try to describe gravity using the rules of quantum mechanics, the whole thing blows up. The math spits out infinities, nonsense, answers that mean nothing. The two greatest theories in the history of science refuse to shake hands. They cannot both be the final word, because they describe the same universe in incompatible ways. Most of the time, it doesn't matter. For big things, you use relativity. For small things, you use quantum, and they never meet. But there are places where they collide head-on. The center of a black hole, where enormous mass is crushed into a tiny point. That's something huge and something tiny at the same time. So you need both theories at once, and they break. The very first instant of the Big Bang, same problem. The entire universe squeezed into a quantum-scale speck. In exactly the most extreme, most interesting places in the cosmos, our physics falls apart. We desperately need a theory of quantum gravity, a single framework that unites the two. Physicists have been chasing it for decades. String theory is one famous attempt, loop quantum gravity is another, there are others. And so far, none of them is confirmed. The holy grail of physics, the unified theory that would knit together everything, remains out of reach. We have two perfect maps that disagree about the territory, and we can't draw the one true map. Now, speaking of black holes, let me take you right up to the edge of one, because they are stuffed with mysteries, and one of them is so profound it's been called a paradox that strikes at the foundation of physics. Picture this. You're floating in your spaceship, watching a black hole from a safe distance. A black hole is a region where gravity is so intense that nothing, not even light, can escape once it crosses the boundary called the event horizon. Cross that line and you're gone, swallowed forever. For a long time, everyone assumed black holes just sat there, eating, getting bigger forever. Then Stephen Hawking did some of the most brilliant work of the 20th century and showed something shocking. Black holes aren't completely black. They very slowly leak energy, a faint glow now called Hawking radiation, and over unimaginable spans of time, far, far longer than the current age of the universe, they actually evaporate. They shrink. They eventually disappear entirely. Okay, cool, but here's the catastrophe hiding in that discovery. Suppose you threw a book into the black hole before it evaporated. All the information in that book, the precise arrangement of every atom, everything that made it that specific book, falls in. Then the black hole slowly evaporates away into that faint, featureless radiation and vanishes. So where did the information go? Here's the problem. One of the deepest principles in all of physics says information can never be truly destroyed. In principle, you should always be able to run the movie backward and reconstruct the past from the present. But if the book falls in and the black hole evaporates into bland, identical radiation that carries no trace of what fell in, then the information is just gone, erased from the universe. And that's supposed to be impossible. This is the black hole information paradox, and it is not some small technical footnote. It's a head-on collision between general relativity and quantum mechanics. The two theories we just said can't get along, and it suggests that one of our most sacred principles is being violated. Physicists have been wrestling with this for decades, with brilliant proposed solutions flying back and forth, and there's still no universally accepted answer. The information might be encoded in the radiation in some subtle way we can't yet read. It might be smeared on the surface of the black hole. It might escape in ways we don't understand. We genuinely do not know. A book falls into a black hole, and the question of where its information goes threatens to unravel physics itself. And it gets even stranger at the very center. Inside a black hole, all that mass is crushed down toward a single point of infinite density, called a singularity, a place where the curving of space and time becomes infinite, where the equations of general relativity give the answer infinity, which is physics speak for our theory has completely broken down here. We literally cannot describe what's at the center of a black hole. It's a place where our laws of nature stop working. And these things are real. We've photographed the shadows of black holes. We've detected the ripples in space from black holes colliding. There are giant ones at the centers of galaxies, including our own, monsters millions or billions of times the mass of the sun. They're out there, all over the universe, and at the heart of every single one is a point where everything we know about physics simply ceases to apply. Wild to think the universe is dotted with these little regions where the rulebook just stops. Let me pull back out and give you one that's been haunting humanity since we first looked up. Are we alone? And here's the specific, sharpened version of that question that drives scientists crazy. It's called the Fermi paradox. Here's the setup. The universe is unbelievably vast and unbelievably old. Our galaxy alone, the Milky Way, contains hundreds of billions of stars. And we now know that planets are everywhere. Most stars have them. Many of those planets are in the comfortable zone where liquid water and maybe life could exist. The galaxy has been around for billions of years. Plenty of time for civilizations to rise. Plenty of time for an ambitious civilization to spread across the whole galaxy, even at slow speeds. By any reasonable estimate, the universe should be teeming with life, and the galaxy should be buzzing with the signs of other civilizations. So the great physicist Enrico Fermi, the story goes, asked the obvious, devastating question over lunch one day. Where is everybody? Because we look, and we see nothing. No signals, no probes, no structures around distant stars, no radio chatter, no clear sign that anyone else is out there or ever has been. The numbers say the galaxy should be crowded. The sky is silent. That contradiction is the Fermi paradox, and it is genuinely unsettling. People have proposed dozens of possible answers, and every single one of them is a little bit terrifying in its own way. Let me run through a few because they are fascinating. Maybe life is just incredibly rare. Maybe the leap from non-living chemistry to a living, reproducing cell is so staggeringly unlikely that it's only happened once, here, and we're effectively alone. That's the lonely answer. Or maybe simple life is common, but intelligent life is the rare part, that the jump to a technological civilization almost never happens. Or here's the dark one. Maybe there's a great filter, some barrier that civilizations almost never get past. And the chilling question is whether that filter is behind us, something we got lucky enough to survive, or ahead of us, some catastrophe that wipes out civilizations before they can spread to the stars, a wall we're racing toward without knowing it. Or maybe they're out there, but the distances are so vast and the time windows so narrow that we keep missing each other, like two ships passing in an ocean bigger than we can imagine. Or maybe, and this one's a head trip, they're aware of us and deliberately staying quiet, leaving us alone, watching. We don't know. We have one example of life in the entire universe, ourselves, and from that single data point, we are trying to figure out whether the cosmos is crowded or empty. It's one of the biggest open questions there is, and every answer changes how you see your place in everything. Which brings us, naturally, to the question underneath that one. How did life even start here, on this planet? Because before you can ask whether there's life elsewhere, you have to ask how non-living stuff ever became living stuff even once. And this is one of the great unsolved problems in all of science, the origin of life, what scientists call abiogenesis. Here's the puzzle. Roll the clock back about 4 billion years. Early Earth is a hot, violent, chaotic place. There are no living things, just chemistry, water, gases, minerals, energy from lightning and volcanoes, and the sun. And then, somehow, at some point, that lifeless chemistry crossed the line and became life. Something that could take in energy, that could copy itself, that could pass information down to the next generation, that could evolve. The very first living thing. And from that single spark, everything, every bacterium, every blade of grass, every dinosaur, every human being, the whole sprawling tree of life on Earth descends. But how? How do you get from a soup of lifeless molecules to a thing that's alive? That's the gap nobody has bridged. Scientists have made real progress on pieces of it. In famous experiments, researchers took the gases thought to be present on early Earth, zapped them with electricity to simulate lightning, and produced amino acids, the building blocks of proteins, right there in the flask. So we know the basic ingredients can form naturally. We can make the bricks. But going from a pile of bricks to a self-copying living cell is a leap nobody has been able to reproduce or fully explain. There are competing ideas about where it happened, maybe in tide pools, maybe at hot vents on the deep ocean floor, where a mineral-rich water gushes up, maybe even seeded by chemistry from space, since we found the building blocks of life in meteorites and comets. And there's a deep chicken and egg riddle baked into it. Living things use DNA to store information, and proteins to do the work. But you need proteins to build DNA, and DNA to build proteins. So which came first? The leading idea points to a molecule called RNA that might be able to do both jobs at once. An RNA world that came before the system we have now. It's a compelling story. But the full path from chemistry to life remains unsolved. The single most important event in the history of this planet, the moment the living world began, and we cannot say exactly how it happened. We are alive, descended from that first spark, and we don't know how the spark was lit. And here's the crazy part to sit with. As far as we know for certain, it only happened once. Every living thing on Earth shares the same basic biochemistry, the same genetic code, which strongly suggests we are all descended from a single common ancestor, one origin event. 4 billion years, an entire planet of opportunity, and the spark of life, at least the one that stuck, seems to have caught exactly one time. Was it a freak accident, a 1 in a trillion fluke? Or is it something that happens easily whenever conditions are right, all over the universe? That question loops us right back to the Fermi paradox. The origin of life and the silence of the sky are two sides of the same coin, and we can't flip it. Now, let me bring this all the way home, into your own skull, because the next great mystery isn't out among the stars or down in the quantum foam. It's the thing reading these words right now. Consciousness. The fact that you have an inner experience at all. And I want you to really stop and feel how strange this is, because it's so close to you that it's almost invisible, like asking a fish about water. Here's the setup. Your brain is made of roughly 86 billion neurons, cells passing electrical and chemical signals to each other in patterns of staggering complexity. We understand a lot about how the brain works as a machine. We can watch which regions light up when you see a face or feel afraid or solve a puzzle. We can trace signals, map circuits, even predict some of your choices from brain activity before you're aware of them. And yet, here's the part that breaks everyone's brain. None of that explains why there's something it feels like to be you. Why isn't all that neural processing happening in the dark, with nobody home? Why is there an experience? Why does red look like something? Why does pain hurt? Why does music move you? Why is there a you in there at all, having a private movie of the world playing behind your eyes? A perfectly good information processing machine could, in principle, do everything you do. React, respond, talk, even claim to be conscious, without there being any actual inner experience attached to it at all. Just lights and switches with nobody watching. So why is anybody watching? Why are the lights on inside you? This is called the hard problem of consciousness, a name coined by the philosopher David Chalmers, and it might be the deepest mystery of all because it's the one doing the asking. We can explain how the eye captures light and how the brain processes it. That's the easy stuff, relatively speaking. What we cannot explain at all is why that processing comes with an inner experience, the redness of red, the actual felt quality of being alive. There's a gaping chasm between the physical brain, all those firing neurons, and the subjective experience, the feeling of being. We have zero idea how you get from one to the other. How does 1.5 kilograms of wet tissue produce the felt experience of tasting chocolate, or falling in love, or the color of a sunset? Nobody can even agree on how to begin answering it. Some think consciousness will turn out to be an emergent property of complex information processing. Some think it's something fundamental, woven into the fabric of reality like mass or charge. Some think the question itself is somehow confused. They are all guessing. The one thing you are most certain of in your entire life, that you exist, that you're having an experience right now, is the thing science is furthest from explaining. And it gets even more vertiginous when you push on it. You assume other people are conscious like you are, that there's an inner light on inside them too. But you can't actually verify that. You only have direct access to your own experience. Everyone else could, in principle, be behaving exactly as if they are conscious, without there being any inner movie at all. Philosophers call this the problem of other minds, and there's no way to truly solve it. You take it on faith every day that the people around you have inner worlds like yours. And here's the thing that ties consciousness to everything else we've talked about. The whole reason any of these mysteries matter, the whole reason there's anyone around to wonder why the universe exists or what dark matter is or how life began, is consciousness. The universe somehow produced inside itself little pockets of awareness that can turn around and ask about the universe. The cosmos became conscious of itself through us. And how that happened, why there's an inner light at all, is maybe the single thing we understand least. The asker is the greatest mystery in the room. Let me give you one more in this stretch that connects the brain to something we all do every single night and still can't fully explain. Sleep, and specifically, dreams. You spend about a third of your entire life asleep. A third. If you live to a decent age, that's decades spent unconscious, lying there vulnerable, defenseless, useless. From an evolutionary standpoint, that should be insane. Sleep makes you an easy target. A creature that didn't need to sleep, that could stay alert and productive all the time, should have a huge survival advantage. And yet every animal sleeps, or does something like it. So sleep must be doing something absolutely essential, something so important it's worth the enormous risk and cost. The problem is, we're still not fully sure what. We have good ideas. Sleep seems to help the brain consolidate memories, clear out waste products that build up during the day, repair the body, regulate emotions. But the deep, complete answer to why we need it, why it's so non-negotiable that you literally die without it, is still not fully nailed down. One of the most basic things every human does, a third of your existence, and the fundamental why is still fuzzy. And then there are dreams, which are even stranger. Every night, your brain conjures up entire worlds, vivid, bizarre, emotional, sometimes terrifying, sometimes beautiful, and you live inside them completely convinced they are real until you wake up. Why? What are dreams for? Are they meaningful messages or just random neural noise your brain stitches into a story? Are they how you process emotions, rehearse for threats, sort through memories? Or are they a side effect of something else entirely? We've been dreaming since before we were human. Every single one of us does it, and we still can't say with certainty what dreams are or why we have them. You will go to sleep tonight, and your brain will build the world and put you inside it. And that, like so much else, remains a genuine mystery. So look at where we've traveled in just this stretch. The fuzzy, observer-dependent weirdness of quantum reality. The spooky instant connection of entangled particles across any distance. The unreasonable way the universe obeys mathematics. The fact that our two greatest theories, gravity and the quantum, refuse to be reconciled. The paradox of information falling into black holes and the broken-down singularity at their hearts. The deafening silence of a galaxy that should be full of life. The unexplained spark that turned dead chemistry into living things. the hard problem of why you have any inner experience at all. And the simple fact that you spend a third of your life asleep, dreaming worlds, for reasons we can't fully pin down. Notice the pattern again. The mysteries aren't just far away in cold space. They run right through the middle of you, through your own mind, your own sleep, your own existence as a conscious thing. The universe is unfinished business at every scale, from the largest black hole to the smallest particle, to the quiet little theater of awareness behind your eyes. And every single one of these is alive right now, an open case, with brilliant people on the trail and no final answer in sight. We've covered a lot of ground, and somehow the list of things we can't explain keeps getting longer the more we learn. That's not a bug. That's the whole adventure. And we're still only partway down. Stick with me, because the next stretch goes somewhere even closer to home and even harder to shake. Okay, so I promised you it gets closer to home, and I meant it. Because now we are going to crawl right inside your own body and your own life, and you're going to find out that the stuff happening under your skin every second is just as mysterious as a black hole. Let me explain, because this one starts with a question so simple it sounds dumb. Why do you age? Think about it. Why don't you just stay young forever? Your body is constantly repairing itself. You heal cuts, you grow new skin, you replace old cells with fresh ones around the clock. Your body is a self-maintaining machine, and a pretty incredible one. So why does that maintenance slowly fail? Why does the machine, over decades, gradually fall apart? Skin wrinkling, bones weakening, memory fading, everything winding down, until eventually it stops. There's no obvious reason a self-repairing system has to decay, and here's the wild part. Aging isn't even uniform across nature. Some creatures barely age at all. There's a kind of jellyfish that can essentially reset itself back to an earlier life stage, cheating death over and over. There are tortoises and certain whales and deep-sea creatures that live for centuries with very little of the breakdown we go through. Some trees live for thousands of years. So aging the way we experience it is not some unbreakable law of biology. It's a thing that happens to us, and we don't fully understand why it has to. We've got pieces of the puzzle. Every time your cells divide, the protective caps on the ends of your chromosomes, called telomeres, get a little shorter, and eventually they are too short to keep going. Damage builds up in your DNA over time. Cells get worn out and stop dividing. Waste accumulates. All of that is real, and it's part of the story. But the deep question, why did evolution build us to break down at all, instead of maintaining us indefinitely, is still genuinely open. One leading idea is brutal in its logic. Evolution mostly cares about getting you to reproduce and raise the next generation. Once you've done that, from evolution's cold point of view, you've served your purpose, and there's little pressure to keep your body in perfect shape. So genes that help you when you're young can be allowed to hurt you when you're old, because by then it doesn't matter to the spread of your genes. That's a chilling thought, that aging might be the price your body pays for being optimized to be young. But it's still a theory, still debated, and the full picture of why we grow old and die is one of the biggest unsolved problems in biology. We've been dying of old age for as long as there have been humans, and we still can't fully explain the why of it. And here's where it gets even stranger, because we don't just age, eventually we die, and death itself is murkier than you'd think. We tend to imagine death as a single instant, a switch flipping from on to off. But it's not. It's a process. When the heart stops, your cells don't all die at once. Different tissues shut down at different rates over minutes and even hours. And the exact moment when a person is truly, irreversibly gone, when you cross the line from could be revived to gone for good, has actually moved over the years as our medicine has improved. People have been brought back from states that would once have been called death, so the boundary itself is fuzzy and shifting. Where exactly is the line between life and death? It turns out that's not a settled scientific fact. It's a moving target. The most certain thing in life, that it ends, and even the precise nature of that ending escapes a clean definition. Now let me shift to something you do every single day without a second thought, and that we still cannot fully explain. The placebo effect. Picture this. You're sick, you're in pain, and a doctor gives you a pill. The pill is completely inert. It's a sugar pill. It contains no actual medicine whatsoever, but you believe it's a powerful drug. And here's the crazy part. You actually get better. Your pain genuinely decreases. Real, measurable changes happen in your body. Not imagined improvement. Real physical effects, measurable in your brain chemistry, your hormones, your immune response. Your belief that you're being treated triggers your own body to heal itself. A sugar pill, doing real work, purely because your mind expected it to. And this isn't some rare quirk. The placebo effect is so powerful and so reliable that every legitimate drug trial has to account for it. To prove a new medicine actually works, you have to show it beats a placebo, because the placebo alone produces such strong real effects that it can be hard to beat. Think about what that's telling you. Your expectations, your beliefs, your mind can reach down and change your physical body in measurable ways, reduce pain, ease symptoms, alter your physiology. And here's the part we can't fully explain. How? What's the actual mechanism by which a thought, a belief, an expectation translates into real chemical changes in your body? We've mapped some of the pathways. We know expectation can release the body's own natural painkillers. We know stress and belief affect hormones and the immune system. But the full picture of how the mind heals the body through pure expectation remains a genuine mystery. And there's an even spookier flip side called the nocebo effect, where if you believe something will harm you, you can actually experience real harmful symptoms from a harmless substance. Your belief can make you sick. The mind-body connection is real, it's powerful, it's measurable, and at its core, it's unexplained. Your own mind is doing medicine inside you, and we don't fully understand the prescription. Which loops us right back to that hard problem of consciousness from before, doesn't it? Because the placebo effect is the mind reaching into the body, and we couldn't even explain what the mind is. These mysteries are all tangled up in each other. Speaking of the mind reaching into the body, let me give you another one that you felt and never questioned. Why does music affect you the way it does? Think about how bizarre this actually is. Music is, at its core, just patterns of vibrating air, sound waves, variations in air pressure hitting your eardrum. That's the raw physical reality of it. Pressure waves, nothing more. And yet, certain arrangements of those pressure waves can make you cry, can give you chills running down your spine, can fill you with joy or crushing sadness, or make a crowd of strangers feel like one connected thing. A particular sequence of notes can transport you back 20 years to a specific summer, a specific person, with overwhelming force. Music can make you want to dance, can pump you up before a fight, can soothe a screaming baby to sleep, can bring an entire stadium to tears at the same instant. Why? Why does organized vibrating air have this enormous power over your emotions? There's no obvious survival reason for it. You don't need to be moved to tears by a melody to find food or escape a predator. And yet every human culture that has ever existed, everywhere on Earth, throughout all of history, has made music. It's universal. It's ancient. We've found musical instruments tens of thousands of years old. It's woven into the deepest parts of being human. And we still can't fully explain why it grips us the way it does, why those patterns of sound reach straight past your reasoning brain and grab your heart. Some think it hijacks the same brain systems we use for emotional speech and bonding. Some think it's tied to movement and rhythm, to how we coordinate as a group. But the deep why is unsolved. One of the most universal and powerful experiences a human can have, and science can't fully tell you why a song can break your heart. Now let me give you one that sits right at the boundary between your body and your sense of self, and it's stranger than people realize. The fact that you are not really you, at least not the way you think. Here's what I mean. Your body contains trillions of cells, but it also contains trillions of bacteria and other microbes, mostly in your gut, that aren't human at all. This is your microbiome, an entire ecosystem of tiny living things that call your body home. And for a long time, we thought of them as just passengers, freeloaders along for the ride. Turns out that's completely wrong. These microbes are deeply involved in running you. They help you digest food, they train your immune system, they produce chemicals your body uses. And here's the part that gets genuinely unsettling. Increasing evidence suggests your gut microbes can actually influence your brain, your mood, maybe even aspects of your behavior and mental health. There's a real communication line between your gut and your brain, and the bacteria living in your intestines seem to be sending signals up it. Which raises a deeply weird question. How much of what you feel, how much of your mood, your cravings, maybe even your decisions, is being shaped by an ecosystem of microbes that aren't even you? Where do you end and they begin? We are only beginning to understand the microbiome, and it's already rewriting what it means to be an individual. You're not a single organism. You're a walking colony, a partnership, a whole world, and the rules of that world are still being figured out. The you that you think is in charge might be sharing the steering wheel with trillions of tiny tenants, and we can't yet say how much. Let me stay inside the body for one more, because this one is wild and you almost certainly have experienced it. Why do you yawn? And why is it contagious? Yawning seems like the most trivial thing in the world, but when scientists actually try to explain it, they hit a wall. The old idea was that you yawn because you need more oxygen, but careful experiments have pretty much knocked that down. Giving people more oxygen doesn't reliably stop yawning. So what's it for? One leading idea now is that yawning might help cool your brain down, like a built-in radiator. But it's still not settled. And then there's the genuinely spooky part. Yawning is contagious. You see someone yawn, or even read about yawning right now, and you feel the urge to do it yourself. Why on earth would a behavior spread from person to person like that? It seems to be tied to empathy, to our deep social wiring, this automatic mirroring of each other. It's even contagious between humans and dogs. But the full explanation for why we yawn at all, let alone why it ripples through a room, is still unresolved. Such a small, everyday thing, and it's a tiny pocket of mystery you carry around with you. Now let me take you somewhere bigger and stranger, into the deep machinery of who you are, and ask a question that science and philosophy have been wrestling with forever. Do you actually have free will? Here's the setup, and it's uncomfortable. Your brain is a physical object made of atoms, obeying the laws of physics. Every thought you have, every choice you make, is the result of neurons firing, chemicals flowing, electrical signals racing around, all of it following physical laws. So when you make a decision, when you choose to raise your hand or order the fish instead of the steak, is that really a free choice? Or is it just the inevitable outcome of physical processes set in motion long before you were even aware of deciding? Because the laws of physics don't seem to leave room for some magical free chooser sitting outside the chain of cause and effect. Everything that happens, including in your brain, seems to follow from what came before. And here's the part that really stirred the pot. Some famous experiments suggested that your brain actually begins gearing up to make a movement a measurable fraction of a second before you consciously feel like you've decided to make it. The decision seems to start in your brain before you become aware of choosing. Read that again. The neural activity that leads to your action can show up before the conscious you feels like it pulled the trigger. So who's really in charge? Is your conscious sense of deciding just a story your brain tells after the fact, a narrator taking credit for choices that were already underway? These experiments are debated, and people argue fiercely about what they actually mean. Maybe they don't show what they seem to. Maybe the picture is more complicated. But the deeper question stands, and it's one of the oldest and most profound there is. If everything is physics, where does free will fit? Are you the author of your choices, or just a witness to them? We do not have a settled answer. The feeling that you're freely choosing is one of the most basic features of being a person, and whether that feeling reflects reality or is a kind of beautiful illusion is genuinely unresolved. Every choice you've ever made, and we can't tell you for sure whether you truly made it. That one messes with people. So let me give you a related head trip that comes straight out of the physics we talked about earlier. Determinism versus randomness. On the big scale, the classical world looks like clockwork, and if you knew the exact position and motion of every particle, in principle you could predict the entire future. That's a fully determined universe, no room for choice. But then quantum mechanics comes in and adds genuine randomness at the smallest scale. Remember those fuzzy clouds of probability, where the outcome of a measurement seems to be truly random, not just unknown, but undetermined until it happens. So is the universe fundamentally a deterministic machine, or is there real randomness baked into it? And here's the kicker. Neither of those actually rescues free will in the way you'd want. If everything is determined, your choices were set in advance. If everything is partly random, then your choices are partly the result of cosmic coin flips, which isn't freedom either. So you're caught between a clockwork universe and a dice-rolling universe, and neither one obviously gives you the kind of free will you feel like you have. Working out exactly how determinism and randomness fit together and what either means for human agency is still wide open. The fundamental nature of cause and effect in the universe is unsettled, and your sense of being a free agent is hanging in the balance. Let me come back up to the surface and give you something you can actually see that has baffled people for a long time and only recently started to crack, though not completely. Why do we have so many of certain everyday biological features that seem useless? Take the appendix. For ages, it was the textbook example of a useless leftover, a vestigial organ that did nothing except occasionally get infected and try to kill you. Why would evolution keep a pointless, dangerous little dead end of an organ? Now there is growing evidence it might actually serve as a kind of safe house for your good gut bacteria, a reservoir to help repopulate your gut after an illness wipes it out. So maybe it's not useless after all. But notice how recent that understanding is, and how it ties right back to that microbiome we talked about. We are still actively discovering the purpose of parts of our own bodies. The instruction manual for the human body has chapters we are still reading for the first time. Now here's one that's pure mystery and genuinely a little eerie, something the medical world has documented but cannot fully explain. Spontaneous remission. Sometimes a person with a serious, advanced, supposedly fatal disease, cancer being the most striking example, simply gets better. The disease retreats. The tumors shrink and vanish, with no clear medical reason, no treatment that should have done it. Doctors are left scratching their heads. It's rare, but it's real. It's documented. And we cannot reliably explain it or reproduce it. Something in those people's bodies turned the tide against a disease that should have killed them, and we don't know what or how. Imagine if we could understand it. if we could figure out what flipped that switch and learn to flip it on purpose. The body clearly has, in at least some cases, an astonishing capacity to heal itself from the brink, and that capacity remains a profound and frustrating mystery. The cure might be hiding inside our own biology, and we can't yet find the key. Let me give you one more in the realm of the mind, because it's so common and so weird and so unexplained. Déjà vu. You've felt it. That sudden, uncanny sensation that you've experienced this exact moment before, this room, this conversation, this precise arrangement of things, even though you know, rationally, that you haven't. It washes over you, vivid and strange, and then it's gone. Almost everyone gets it, and we still don't have a settled explanation for what's happening in your brain when it strikes. Is it a tiny glitch in memory, where a new experience accidentally gets tagged as a memory? Is it a brief mismatch in timing between two parts of your brain so that an experience gets processed twice with a tiny delay and the second pass feels like a recollection? Is it your brain noticing a faint similarity to some real past experience you can't consciously recall? There are several theories, and none of them is confirmed. One of the most common strange experiences a human mind can have, something nearly everyone has felt, and the explanation is still up in the air. Your own brain produces this little ripple in your sense of time and reality, and it won't tell us how. So step back again and look at the territory we've covered just in this stretch. Why you age when nothing says a self-repairing body has to break down. The fuzzy, shifting line between life and death, the placebo effect, your mind healing your body through pure belief, and the nocebo effect, your mind harming it the same way. The way music, just patterns of vibrating air, can shatter your heart or lift your soul. The trillions of microbes that aren't you, but might be shaping your moods and choices. The simple contagious yawn we can't fully explain, the deep, unsettling question of whether you have free will or are just watching choices your brain already made. The tug-of-war between a determined universe and a random one, with your agency caught in the middle. The organs in your own body whose purposes we are still discovering. The miracle of spontaneous remission, healing we can't explain or repeat. And déjà vu, that little glitch in your sense of having lived a moment before. And here's what I want you to really feel. Every single one of these is inside you, or about you, right now. You are not a solved problem. You are walking around as a living, breathing collection of open scientific mysteries. The thing reading these words doesn't fully understand why it ages, why it dreams, whether it's truly free, why a song makes it cry, or how its own beliefs reshape its body. We've sent probes to other planets and split the atom and mapped the genome, and you, the ordinary person sitting there, are still in huge part a riddle to science. That's not a knock on science. It's a reminder of how deep the well goes, even right here under your own skin. The frontier isn't only out there past the stars, it's you. And we are not done. There's still one more stretch ahead, and it pulls all the way back out to the very biggest picture of all, the questions about everything, the ones that decide what all of this even means. So stay with me, because the finale is where it gets the most staggering of all. Okay, so we've crawled inside your body. We've fallen into black holes. We've stared at the quantum foam. Now let's pull all the way back out, further than we've gone yet, to the absolute biggest picture there is. The questions about everything. The ones that don't just ask how the universe works, but what the whole thing even means. Buckle up, because this is the deep end, and it's where it gets the most staggering of all. Let me explain. Start with one that physicists actually lose sleep over, even though it sounds like something out of a late-night dorm room conversation. Why are the laws of physics exactly the way they are? Here's the setup. The universe runs on a handful of fundamental numbers, constants they are called. The strength of gravity, the strength of the force holding atoms together, the mass of the basic particles, the amount of dark energy pushing space apart. These numbers are baked into the fabric of reality, and as far as we can tell, they didn't have to be the values they are. And here's the part that'll freeze you. If you nudged some of these numbers even slightly, just a tiny bit in either direction, the universe would be a dead, empty place. Make gravity a hair stronger, and the universe would have collapsed back on itself almost immediately. Make it a hair weaker, and matter could never have clamped into stars and galaxies. Tweak the force that binds atomic nuclei, and stars couldn't make the carbon that life is built from. Across the board, the constants of nature seem to be set with absurd precision to allow stars, planets, chemistry, and life to exist. It's as if someone dialed in the settings on a cosmic control panel with impossible care. This is called the fine-tuning problem, and it is one of the most profound puzzles in all of science. Why is the universe so suspiciously perfect for existence? And here's the thing, nobody has a confirmed answer, and the possible answers are all mind-bending. One idea is that it's just luck, a coincidence, and we shouldn't read too much into it. But the precision is so extreme that pure coincidence feels unsatisfying to a lot of physicists. Another idea reaches back to that multiverse we talked about. If there are countless universes, each with different random settings for the constants, then most of them are dead and lifeless. But a few, by sheer chance, get the settings right. And of course, we find ourselves in one of the rare livable ones, because we couldn't exist anywhere else. That's a clever escape, but remember, the multiverse might be fundamentally untestable, which makes some scientists deeply uncomfortable calling it an answer. And then there's the possibility that there's some deeper law we haven't discovered yet, one that forces the constants to be exactly what they are. So they're not free dials at all, but locked in by some principle we can't yet see. We don't know. The universe appears to be exquisitely tuned for its own existence, and we cannot explain why. Whether it's chance, a multiverse, a hidden law, or something else entirely is wide open. The settings of reality are perfect for us, and the reason is one of the deepest unsolved questions there is. Which leads straight into a question so wild that serious, sober scientists actually debate it. Are we living in a simulation? Now, before you roll your eyes, hear the logic out, because it's sharper than it sounds. Here's the argument. Suppose that advanced civilizations can eventually build computers powerful enough to simulate entire conscious worlds, universes full of beings who feel real, who think they're alive, who never suspect their code. If that's possible, then a sufficiently advanced civilization might run not just one such simulation, but millions or billions of them, ancestor simulations, virtual worlds spun up for research or curiosity or entertainment. And here's the gut punch. If there are billions of simulated worlds and only one real one, then statistically, the odds that you happen to be living in the single original reality rather than one of the countless simulations are tiny. By the numbers, you're far more likely to be a simulated being than a real one. That's the argument, and it's been laid out carefully by serious thinkers. It is genuinely hard to refute on pure logic. And here's what makes it more than just a thought experiment. Some people point to features of our universe that, if you squint, look a little suspicious. The fact that there's a fundamental speed limit, the speed of light, the way a video game has a maximum render distance, the fact that reality seems to come in discrete little chunks at the smallest scale, almost pixelated, the way a digital image is made of pixels, the weird observer-dependent behavior of quantum mechanics, where things seem fuzzy and undetermined until they are looked at, almost like a game that only renders detail when a player is watching to save processing power. Now, none of that proves anything, and plenty of scientists think the whole idea is unfalsifiable nonsense. But here's the honest, uncomfortable truth. We cannot currently prove that we are not in a simulation. There's no experiment we've found that definitively rules it out. The question of whether everything you've ever experienced is fundamental reality or an elaborate computation running on some vast machine in a parent universe is, astonishingly, an open one. We don't know what the ground floor of reality even is. That should keep you up at night a little. Now, let me hit you with one of the deepest, oldest, most beautifully strange questions in all of mathematics and physics. And it connects to everything. Is the universe infinite? Does space go on forever, endlessly, in every direction without limit? Or is it finite somehow? You'd think we could answer this. We can't. We can only see a certain distance, the observable universe, the bubble of space from which light has had time to reach us since the Big Bang. Beyond that edge, there's almost certainly more, but we literally cannot see it, and we can't tell whether it goes on forever or eventually closes back on itself. And here's where it gets truly dizzying. If the universe is infinite, then something staggering follows. In an infinite universe with matter arranged the way ours is, every possible arrangement of matter would have to repeat. Somewhere out there, infinitely far away, there would be another Earth, another you, reading these exact words, and not just one, infinitely many copies of you, living out every possible variation of your life. An infinite number of versions of you who made every different choice, lived every different life. That's not mysticism. That's just what infinity implies if it's real. And we cannot say whether it's real. Whether space is endless or bounded is one of the most fundamental facts you could possibly want to know about the universe you live in. And the honest answer is, we do not know. And here's a related one that should stop you cold. How will it all end? We talked about the universe accelerating, flying apart faster and faster because of dark energy. So what's the ultimate fate of everything? There are competing scenarios, and they're all extraordinary. In the most likely picture, given what we currently know, the expansion just keeps going, faster and faster, forever. Galaxies fly out of sight one by one. Stars burn out and aren't replaced. The universe grows colder, darker, emptier, more spread out, until it's a vast, frozen, lightless void where nothing happens anymore and nothing ever can. A slow, quiet heat death, the universe winding all the way down to nothing. That's one ending. But there are others. If dark energy behaves differently than we think, the acceleration could run away so violently that it eventually rips apart galaxies, then stars, then planets, then atoms themselves, in a finale called the Big Rip, where space tears everything to shreds. Or, if the expansion somehow reversed, everything could collapse back together into a fiery crunch. We genuinely don't know which fate awaits everything, because it all hinges on the true nature of dark energy. And remember, dark energy is the thing that makes up most of the universe and that we cannot explain. So the ending of the entire story, the fate of all that exists, is locked behind a mystery we haven't cracked. The universe will end somehow, and we can't tell you how the book closes. Let me bring it back from the end of time to a question that's haunted thinkers for ages and ties right into all of this. Why is the universe comprehensible at all? Sit with this one, because it's subtle and it's profound. There's no rule that says a universe has to be understandable by the creatures inside it. The cosmos could have been an incomprehensible chaos, a place with no patterns a mind could grasp, where nothing made sense and prediction was impossible. Instead, we find ourselves in a universe that follows consistent laws that a brain evolved on the savannah to dodge predators and find fruit can somehow uncover, write down, and use to predict the behavior of things billions of light years away or smaller than an atom. Einstein himself marveled at this. He said the most incomprehensible thing about the universe is that it's comprehensible. Why should reality be the kind of thing a mind can understand? Why should there be deep order rather than chaos? And why should we, tiny and recent and fragile, be capable of reading it? It's almost too good. And we have no explanation for why the universe is set up to be knowable, or why we're equipped to know it. The fact that this whole adventure of science is even possible is, itself, an unexplained gift. And here's a humbling twist on that. Even if the universe is comprehensible, are we smart enough to comprehend all of it? Think about a dog. A dog is intelligent. It can learn, it loves you, it solves little problems. But a dog will never understand calculus. Not because it's not trying hard enough, but because its brain simply isn't built for it. The concept is forever beyond its reach. So here's the unsettling question. Are there truths about the universe that are, in the same way, forever beyond the human brain? Concepts so far past our cognitive limits that we couldn't grasp them no matter how long we tried, the way a dog can't grasp calculus? Maybe the deepest answers, what consciousness is, why there's something rather than nothing, what came before the Big Bang, are simply outside what a human mind can hold, and will forever be like that dog, sensing there's something there but unable to reach it. We have no way of knowing whether that's true, which is its own kind of mystery. The limits of our own understanding might be a hard wall we can't even see. That's a profoundly humbling thought, and it's completely unresolved. Now let me give you one that wraps physics and philosophy together in the tightest knot of all. What is reality made of at the very bottom? We dig down. Solid objects turn out to be made of molecules. Molecules are made of atoms. Atoms are mostly empty space, with a tiny nucleus and a cloud of electrons. The nucleus is made of protons and neutrons. Those are made of quarks. And quarks and electrons are, as far as we know, fundamental, not made of anything smaller. But what are they really? In our best theories, these fundamental particles aren't really tiny balls of stuff at all. They are described as excitations in fields, ripples in invisible fields that fill all of space, a kind of vibration in something we can't picture. So when you knock on a table and it feels solid, what you're really feeling is, at the deepest level, patterns of energy in fields, governed by math, with no little nuggets of solid stuff anywhere to be found. The solidity is, in a sense, an illusion built out of forces and fields. So what is the universe actually made of at the very foundation? Is it fields? Is it information? Is it pure mathematics somehow made real? Is there even a bottom at all, or does it go down forever? We genuinely don't know what the ultimate substance of reality is, or whether ultimate substance is even the right way to think about it. You are made of atoms, which are made of particles, which are made of fields, which are made of, we don't know. The floor of reality is a question mark. And here's maybe the strangest realization of all when you put it all together. The universe produced, inside itself, creatures capable of asking what the universe is. That's us. Out of the lifeless chemistry and the fields and the fine-tuned constants, after billions of years, the cosmos folded up a little piece of itself into a brain that can look back at the whole thing and wonder. The universe became aware of itself through you. And the deepest mysteries, why it exists, what it's made of, how it began, how it ends, why there's anyone here to ask, are being asked by the universe about itself through these brief conscious sparks that we are. There's something almost unbearably beautiful in that. We are the universe's way of trying to understand itself, and we've only just begun, and we may never finish. So let me bring it all home, because we've traveled an enormous distance together, you and me. We started with the simplest, deepest question of all. Why is there something rather than nothing? And we couldn't answer it. We couldn't say what triggered the Big Bang, or what started and stopped cosmic inflation. We found out that 95% of the universe, the dark matter and the dark energy, is stuff we cannot see or explain. We discovered that time only flows forward for reasons buried in an inexplicable initial order at the dawn of the cosmos. We stared into the vast empty voids hundreds of millions of light years across, and we asked why you, alone among all living things, cry from emotion. Then we went smaller and stranger, the fuzzy, observer-dependent weirdness of quantum reality. Particles that go through two slits at once and change their behavior when watched. Entangled particles linked across any distance with no connection we can find. The unreasonable way the universe obeys mathematics. The fact that gravity and the quantum, our two greatest theories, refuse to be reconciled. The paradox of information lost in black holes and the broken singularities at their hearts. The deafening silence of a galaxy that should be full of life. The unexplained spark that turned dead chemistry into the first living thing. And the hard problem of consciousness, why there's anyone home inside you at all. Then we came home, into your own skin, why you age and die when nothing says a self-repairing body must break down. The placebo effect, your mind healing your body through pure belief. Why music, just vibrating air, can break your heart. The trillions of microbes that aren't you but might shape your moods. Whether you truly have free will or just witness choices your brain already made. Spontaneous remission, déjà vu, dreams, yawns, a whole crowd of everyday mysteries you carry around inside you. And finally, we pulled all the way back out to the biggest questions of all. Why the constants of nature are tuned with impossible precision for our existence. Whether we are living in a simulation, whether space goes on forever with infinite copies of you out there in the dark. How it all ends. Why the universe is comprehensible at all, and whether we are even smart enough to comprehend it. What reality is made of at the very bottom, and the staggering fact that the universe woke up inside itself and started asking these questions through us. Now here's the thing I really want you to take away, because it's easy to hear all this and feel small, or even a little hopeless. Don't. Because every single one of these mysteries is not a wall, it's a door. We tend to picture science as a finished encyclopedia, a closed book of settled facts handed down by people in white coats. But that's not what science is at all. Science is the most exciting, ongoing, unfinished adventure our species has ever undertaken. It's a story still being written, and the most thrilling chapters haven't been written yet. Everything we covered today is a live, open question right now, with real people on the trail, building detectors deep underground to catch dark matter, smashing particles together to find the bottom of reality, peering at the faint glow of black holes, mapping the brain to chase down consciousness, scanning the skies for any whisper of company. The frontier is wide open, in every direction, at every scale, from the largest void to the smallest particle, to the quiet theater behind your own eyes. And here's the part that gives me chills. The person who finally cracks one of these, who figures out what dark matter is, or what came before the Big Bang, or how dead chemistry first became alive, or why we have an inner experience at all, that person is alive right now. Maybe they are a kid staring at the ceiling tonight, asking the same questions you just asked. Maybe, in some small way, it's you. The not knowing isn't a failure. It's the fuel. It's the entire reason anyone has ever built a telescope or peered into a microscope or studied the chemistry of a single tear. We do all of this precisely because we don't know yet. The unknown isn't something to fear. It's the greatest invitation there is. So the next time someone tells you science has everything figured out, you'll know the truth. The honest truth is that the universe is still, in the deepest sense, an unsolved mystery from top to bottom, from why anything exists at all, right down to why you cry. And that's not a reason to stop looking. It's the best reason in the world to keep looking. Because the story isn't over. Not even close. We've only read the first few pages of a book with no known ending, and somehow, impossibly, we're the ones reading it. The universe is still riddled with questions we cannot answer, and that, more than any answer ever could, is what makes being alive and awake in it so unbelievably good. Thanks for taking this ride with me. Keep wondering, keep looking up, and never let anyone convince you it's all been figured out. Because it hasn't, and that's the most beautiful part of all.